On August 15, 1977, a radio telescope in Ohio picked up a signal that would baffle scientists for decades. It lasted just 72 seconds, a spike of energy unlike anything the telescope had ever recorded. Astronomer Jerry Ehman circled the signal on the printout and wrote a single word in the margin. Wow. And that name has stuck ever since. The signal came from the direction of Sagittarius, a region of the sky filled with stars, gas, and dust. It was a narrowband transmission, extremely precise in frequency, unlike natural cosmic phenomena. For decades, researchers searched for a repeat. Nothing. Silence. Yet the characteristics of the signal suggested an intelligent source, or at least a highly unusual cosmic anomaly. The first puzzle was the frequency. The signal sat exactly at 1420 megahertz, the natural emission line of neutral hydrogen. Hydrogen is the most abundant element in the universe. Many scientists consider this frequency ideal for interstellar communication because any advanced civilization would know to use it. And yet, despite its significance, the signal appeared only once, never to repeat. Over the years, researchers tried every explanation: instrument error, terrestrial interference, satellite reflections, atmospheric phenomena. None fit. Every test returned the same conclusion: the wow signal was real, and it didn't behave like anything we understood. The signal's brief appearance raises another question. Why only once? If it were a transmission from an intelligent source, why not repeat? Some hypothesize it was a brief beacon, a message sent only once, or perhaps a probe passing through our solar system, emitting a short burst. Others suggest it could be an unknown astrophysical phenomenon, something the universe does occasionally, but rarely enough to escape classification. The lack of repeatability turned the wow signal into a data anomaly. It sits in the archives of SETI, the search for extraterrestrial intelligence, as a single point of interest, unexplained, unreplicated, and tantalizing. Modern AI analysis can process decades of radio telescope data to search for similar anomalies. Even with massive datasets spanning millions of observations, no pattern emerges. The wow signal remains unique. Its persistence in the scientific record, despite uncertainty, reveals a broader lesson. Anomalies are often the most important data points. They may not fit existing models, but they point to gaps in our understanding. In other words, the signal didn't just challenge astronomy, it challenged how we analyze data itself. The implications of the wow signal are subtle but profound. It suggests the universe may contain phenomena we cannot yet explain. It highlights the limitations of human observation. Signals can be missed or dismissed. It shows that even a single anomaly can spark decades of research and debate. It is a perfect example of a needle in a haystack, a rare data point with enormous potential significance. Some researchers have revisited the archives using modern AI tools, cross-referencing the original Ohio data with other radio telescope observations worldwide. The AI highlights patterns humans might never notice: weak correlations, timing coincidences, unusual spectral signatures. Yet even with this computational power, no definitive explanation has emerged. The mystery remains. This teaches a key lesson for every data after dark investigation. Rare anomalies matter. One brief unique signal can hold enormous significance. Human oversight has limits. Even trained observers can overlook critical data. AI amplifies insight. Algorithms can detect correlations humans would miss, but some mysteries remain unsolved. Curiosity drives discovery. The search itself often leads to insights beyond the original anomaly. The wow signal is not just a curiosity, it's a reminder that the universe still holds secrets waiting to be noticed. If you want to explore more hidden anomalies in science, space, and history, signals that almost went unnoticed but could change everything, subscribe to Data After Dark. Because sometimes the most important discoveries are the ones that appear for just 72 seconds and vanish.